the experiment that nearly ended an era. It was meant to be a footnote, a controlled trial, limited in scope, safely contained within a laboratory of ideas. No one expected it to threaten an entire era of automotive thinking. But within months, this single experiment began unraveling assumptions the industry had relied on for generations. At the time, everything felt stable. Platforms were mature, regulations predictable. Progress followed a familiar rhythm of upgrades and refresh cycles. The automotive world believed it understood its own limits, and that confidence made it vulnerable. The experiment began with a simple question that sounded harmless enough. What if efficiency, safety, and performance didn't need to compete at all? What if the trade-offs everyone accepted were artifacts of outdated thinking rather than physical necessity? The team behind the project wasn't chasing headlines. They were researchers, systems thinkers, engineers obsessed with first principles. They weren't tasked with building a car. They were asked to test an idea, one that required dismantling how vehicles were designed, validated, and evaluated from the ground up. They started by questioning segmentation. Why were engines optimized separately from structures? Why did safety systems activate only after failure instead of preventing it? Why were efficiency gains treated as compromises instead of multipliers? The experiment refused to isolate problems. It treated the car as a single, living system. Early models existed only in simulation. Digital frameworks where propulsion, structure, aerodynamics, and control logic evolved together instead of in sequence. The results were confusing at first. Traditional benchmarks broke down. Improvements stacked instead of canceling each other out. Gains appeared where theory predicted loss. When the first physical prototype emerged, it didn't look revolutionary. No dramatic styling. No radical proportions. That was intentional. The danger wasn't how it looked. It was how it behaved. During initial tests, the machine delivered efficiency figures that defied expectations without sacrificing stability. Safety margins expanded instead of shrinking. Performance improved without demanding additional complexity. The data suggested something unprecedented. A system where progress in one domain strengthened every other. Engineers outside the project reacted with disbelief. Some accused the team of manipulating test conditions. Others demanded replication under stricter oversight. Leadership approved expanded trials, confident the results would normalize under scrutiny. They didn't. Instead, the experiment grew stronger, and as word spread quietly through technical circles, a realization began to form, one that unsettled everyone who understood it. If this experiment scaled, it wouldn't just improve cars. It would invalidate the era built on compromise. And that kind of discovery doesn't just change industries, it ends them. As the experiment moved beyond theory, resistance hardened into fear. Engineers from outside the project were brought in to audit the results, expecting to expose hidden flaws or unrealistic assumptions. They arrived armed with skepticism and left with questions they couldn't easily answer. The prototype behaved consistently across scenarios that normally forced trade-offs. Increased safety margins and efficiency rose. Improved efficiency and thermal stress declined. Push performance. And structural loads distributed themselves more evenly. Every lever pulled seemed to reinforce the others. The system refused to behave like anything engineers had been trained to expect. The key wasn't a single breakthrough component. It was coordination. The experiment treated energy as a shared language rather than a resource to be isolated. Waste heat fed structural management. Aerodynamic flow stabilized control systems. Braking energy reshaped traction strategy. Nothing operated alone. The car didn't react. It anticipated, not through prediction, but through balance. That balance threatened more than competitors. It threatened institutions. Regulatory models depended on compartmentalization. Safety certification assumed failure first, response second. Manufacturing relied on modular independence. Even education taught engineers to specialize, not synthesize. This experiment didn't just challenge products. It challenged how expertise itself was organized. Leadership demanded boundaries. They ordered the team to isolate variables, to prove which part of the system delivered the gains. The team tried and failed. Remove one interaction, and the entire advantage collapsed. The experiment only worked as a whole. It couldn't be disassembled without destroying the result. That revelation ignited panic. If the system couldn't be reduced, it couldn't be easily regulated. If it couldn't be modularized, it couldn't be easily manufactured. And if it couldn't be explained in familiar terms, it couldn't be marketed or insured. The more successful the experiment became, the more dangerous it looked. Meetings shifted tone. What began as curiosity became containment. Leadership reframed goals from exploration to risk mitigation. Questions changed from how far can this go to how do we stop it from going too far? The team sensed the shift immediately. Budgets tightened, access narrowed, oversight increased. Requests for additional testing were delayed or denied. The experiment was no longer seen as an opportunity. It was seen as a destabilizer. And yet, the data continued to arrive, relentless and undeniable. Long-duration trials showed unprecedented component longevity. Failure mode softened instead of cascading. Driver workload dropped measurably. The machine didn't demand perfection. It absorbed imperfection. Quietly, engineers across the company began asking an unthinkable question. If this works, why are we still doing things the old way? That question spread faster than any prototype. And once it reached the people whose careers were built on the old way, the experiment's fate was sealed. Because revolutions don't usually end when they fail. They end when they succeed too clearly. The success triggered a quiet shutdown, disguised as caution. Leadership announced a restructuring of priorities. Officially, it was about focus and efficiency. Unofficially, it was about control. The experiment had gone too far, too fast. And in doing so, it exposed weaknesses not in technology, but in the structures meant to manage it. The research team was asked to pause scaling efforts. Access to shared data was restricted. Cross-department collaboration was discouraged. What once felt like a breakthrough lab now felt like a quarantine zone. The machine still existed. The results were still real. But momentum was being suffocated deliberately. The engineers pushed back with evidence. They demonstrated how the system reduced long-term costs instead of increasing them, how safety margins expanded without regulatory exceptions, how manufacturing complexity actually decreased once interdependencies were understood rather than avoided. They argued that the experiment didn't demand chaos. It demanded evolution, but evolution threatened power. Senior architects realized their expertise no longer applied cleanly. Managers saw roadmaps dissolving. Consultants couldn't package the discovery into familiar frameworks. The experiment made specialists feel obsolete, and institutions responded to that feeling with fear. The final blow came during a closed executive review. A risk committee concluded that the experiment created systemic uncertainty, not because it failed, but because it succeeded in ways that could not be isolated, owned, or predicted through traditional oversight. The recommendation was clear. Terminate the project before it redefined expectations the organization could not meet. The engineers were given a choice. Refocus the research into incremental subsystems that could be safely absorbed, or watch the entire project disappear. Some left immediately, unwilling to dismantle what they believed was the future. Others stayed, determined to salvage fragments. The original prototype was locked away, its holistic architecture frozen in time. Yet even in containment, the experiment refused to die. Concepts leaked into other programs. Engineers carried the philosophy with them into new roles, new companies, new countries. Quietly, unknowingly, the industry began changing, not because the experiment was adopted, but because it had infected how problems were seen. The era of compromise didn't end overnight, but it cracked. And that crack began with a single experiment that proved something deeply unsettling. The limits everyone accepted were not physical. They were organizational. And once that truth is discovered, no era ever ends the same way again. The official end of the experiment came without drama. No cancellation announcement. No acknowledgement of what had been discovered. Just a quiet reallocation of resources, a change of language, and a careful erasure from roadmaps. On paper, the project never failed. It simply concluded. But conclusions do not erase consequences. The engineers who remained understood what happened. The experiment wasn't ended because it was dangerous to drivers. It was dangerous to certainty. It challenged the belief that progress must be incremental, that systems must be separable, that control depends on predictability. And institutions built on predictability do not survive revelations that expose it as an illusion. Years later, fragments of the experiment began appearing across the industry, not as a single philosophy, but as echoes, safety systems that prevented instability instead of reacting to it, powertrains that shared energy intelligently rather than wasting it, structures designed to redistribute stress rather than resist it. No one credited the original project. No one connected the dots publicly, but those who had been there recognized the patterns immediately. The era did not collapse. It adapted, slowly, reluctantly, selectively, and that was the compromise history settled on. The original prototype was eventually dismantled, its data archived, its purpose fulfilled without recognition, but its influence lived on in a subtler way. Engineers stopped asking how to optimize parts. They started asking how to harmonize systems. That shift didn't make headlines. It didn't end quarterly eras or rewrite slogans, but it quietly redirected the trajectory of automotive design. The age of isolated brilliance gave way to the age of integration, not because it was fashionable, but because it worked. The experiment that nearly ended an era did something more precise. It ended certainty. It proved that the way things are done is rarely the way they must be done. That progress doesn't always announce itself with disruption. Sometimes it enters as a question so fundamental, it destabilizes everything built on the answer. And once that question exists, no era ever truly survives it intact. Sometimes the smallest shift in perspective becomes the beginning of a new future. The